Alrighty, so we're on to law of cosines. So the reason we need law of cosines is not every triangle scenario can be solved using law of sines. Law of sines is only helpful to us if we know an angle and a side across from it. So we have that relationship. So if we know three sides, side, 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 or side, angle, side, um, so the included angle, it's not going to help us at all, law of sines, because I don't have that relationship. So there are other scenarios we need to address, and that's where law of cosines comes into play. So for our first day here, our essential questions are how can we use law of cosines then, easy for me to say, to help solve these two different types of triangles, and then also to model some real life problems. So what would be a situation that you would use something like this? So that's what we're going to be talking about today. So first order of business, we need to get our law of cosines jotted down. So go ahead and take a moment to pause the video so you can jot down what you need here. We have two different forms for law of cosines. One that's solved for a side measurement, so the a squared, b squared, c squared. So if you are solving for a side, that's a great form to be able to use because the side is by itself. So the reason we'd use standard form is if we were trying to solve for a side of a triangle. So if we knew, in other words, two sides in the included angle, so side, angle, side, that's when we'd be using that standard form. So if we know an angle measurement and the two other sides, then that included angle, great form. We also have an alternate form, which is basically just taking the standard form and solving it for the angle measurement, or actually cosine of the angle. That's a great format when you're solving for an angle. So if your quest is to solve for an angle measurement, in other words, you have side, side, side. That's the form that you would want to use. So it's a little bit easier way to just get right to that, so you don't have to do all the solving yourself. So that alternate form is really handy. So depending on what we're solving for, we'll choose one over the other, but they're both the same form or the same formula, just solve for different things. So whether we're solving for a side or an angle. So law of cosines is going to help us in those two scenarios, side, 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 and side, angle, side. So we need to do a little bit of talking about in what order are we going to solve for things given different information. So we're going to look at an example of each format, a side, 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 and a side, angle, side, and kind of talk strategy, I guess, a little bit. So we'll start with a side, side, side. What if we're given three lengths? So we have three sides of the triangle. Which of those angles should we be solving for first? Because we don't know any of the angles, right, if we know three sides. So which angle should we find first? Think about that for a second. Think about what you know about triangles. What would be the best thing to calculate first? Well, here's what we really need to do. We need to find the largest angle first. So remember what the largest angle would be across from the longest side. Then you know for sure what kind of triangle you're dealing with, right? So then you know for sure whether that triangle is going to be obtuse or acute. If we find the biggest angle first and it's bigger than 90, we know we have an obtuse triangle. That means the other two angles will be acute for sure. If we find the biggest angle and it's acute, that means the other angles are also going to be acute, right? If the biggest angle is less than 90, then the other two as well. We know what kind of triangle we're dealing with. If we find the smallest angle first, for example, we really have no idea what's going to happen for the other two. So it's really important, if we're given three sides, we want to find that biggest angle measurement first, so across from the longest side. So since it's the longest or the largest angle, you're going to know the other side or the other angles have to be acute. It just gives us a little bit more information. So if you have a side, side, side scenario, we want to make sure that we find that biggest one first. All right, so let's jump right into one of these. So it says, using the triangle at right, find the angle A. They're giving you a picture. They could also just list the side or the side length, so you'd have that as well. And it says, then find the remaining angles. I added that. I want to find the whole thing. I want to go through and solve this entire thing so we find all the missing pieces. So remember how we label these things. So side A is across from angle A. So side A is 20, side B is the 18, and then side C is the 13. So across, always across the triangle. So we have side, side, side. So that's what we know about this triangle. We have three sides. So what we want to do is we want to find the biggest angle first, so we know what kind of triangle we have. So which angle would be the biggest? Well, it's the one across from the longest side, which is side A. So we should be finding angle A first, which is what they're asking us to do. But normally they're not going to ask you, right? You're just going to have a triangle and you're going to have to know. So we want to find angle A first because it's going to be the largest. So then we're going to know what kind of triangle this is. Don't assume either by the shape of the triangle that they give you that it is is drawn to scale, because just so you know, I believe your textbook uses this little triangle picture for no matter what the triangle looks like. So think about, just make sure you know what you're doing. So we want to find angle A. So let's go back to our formulas for law of cosines. We know side, 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 so we want to be using this alternate form because we're trying to solve for an angle. So these are the ones that are solved for the angles, and we want to use the one that has the same lettering. So we're going to use that cosine of A. So that's the one I'm going to start with. So let's go ahead and we're going to jot that down. So the great thing about this is we can just substitute in the values and we can do our solving. So we can put in our b squared, so 18 squared, plus c squared, which is 13 squared, minus a squared, 20 squared, over 2 times b times c. And we just need to do that calculation. And then that's what cosine of a is. Remember, then we're going to have to do inverse cosine to get that angle measurement. So let's go ahead and grab the calculators here and see what we can do with this. I want to make sure that you're calculating this correctly, you're getting the right number. We don't really have to worry about simplifying it a whole lot. We just need to get the accurate value in the calculator and then be sure we can find that angle measurement. All right, so I did the numerator and the denominator, so then I'm just going to go ahead and divide those. So 93 divided by 468 is going to give us a decimal value. Great. That's what cosine of A is equal to. So then what I want to do is find the inverse of that, so inverse cosine. Now double check, what mode should your calculator be in? We're dealing with degree measures, so double check, make sure you're in degrees. That's a really common error that people will make. So double check that your mode is in degrees, and we're going to do inverse cosine of our answer, and we're going to get an angle value, so 78.5. I'm going to go ahead and just round to tenths as well, so that should be fine. So I had cosine of A, just to get my work on here, was 93 over 468, and I did inverse cosine, right, to get the angle measurement, which was about 78.5. So it's approximately 78.5 degrees. So we have our angle A as 78.5. Now that was the biggest angle in the triangle, right? So now I know that this is an acute triangle because the largest angle is less than 90. So that means the other two angles will also be less than 90. All right, so we found our angle A. Awesome. Now we need to find the remaining two angles. We have to find angle B and C. Let's talk strategy. Now we know everything about A, don't we? We have angle A and we have side A. We know everything about A. So I don't have to use law of cosines again because I can use law of sines now to find another angle. So that's the really cool thing about law of cosines. We can go back for those other pieces using things that we already know. So we're going to find the next angle. So we're going to find the next one by using law of sines. So we're going to find the next angle using law of sines. So we can use everything we know about angle A and side A to do that. So let's see what we want to find next. So let's go ahead and kind of keep going down. We'll find the next largest angle. So I'm going to just find angle B. So we can set up our law of sines. 20 is to the sine of angle A, which is 78.5, as 18, side B, is to the sine of angle B. So we're going to cross multiply, divide, and we're going to have to use inverse, right, because we're solving for an angle. Now, I wrote down the rounded version of that angle measurement. It might be good, though, when you're actually doing the calculation to use the actual all the values. If you don't, you're going to be just off a couple decimal points. Just so show your work so I know what you did. So if you don't have that number still on your screen, if you put in the 78.5, just realize your answer will be a little bit different than if you put in the whole 78 point, whatever, the whole decimal value. All right, so we're going to cross multiply and divide. So the inverse, or the sine of B, we'll start there, would be 18 times the sine of 78.5 divided by 20. And then remember, we have to do inverse. So inverse sine of 18 times the sine of 78.5 divided by 20. Everybody sort of has their different way of typing this in. For me, I kind of like to do it all in one step if I can. So I can type in all of it. So I can start off with just inverse sine. If you want to do it in pieces, we can definitely do that too. So 18 times the sine of, now I'm just going to type in 78.5 just so you can see what that would look like. Remember to finish off that parenthesis, and then divided by 20. And then I'm going to take the inverse sine of my answer. So I should be coming up with something in the 61.9-ish ballpark there. If you use all the decimal points, it might be off again by just a little bit. So inverse sine, that's going to give me about 61.9 degrees. So I have my second angle. So I know angle A is 78.5, and I know angle B is 61.9. A little bit less because that side length was a little bit smaller. So how do I find the last angle? So how do I find my third angle? Well, don't you already know the other two? For sure. So how do you find a third angle in a triangle? What do they all add up to? 180 degrees. So to find the third angle, we just subtract from 180. So we subtract the other two angles from 180. So that third angle is always going to be a pretty quick calculation. So we're going to take 180 degrees minus our other two. And again, I'm just going to use the rounded versions here, which is totally fine. And let's see what we come up with then. So angle C, go ahead and do that quick calculation here. 39.6. Double check my arithmetic there. I think that looks good. So think about what we just calculated here. I'm going to go back up to the triangle. So we've got our 39.6 degrees and we had our 61.9. So the smallest angle is across from the shortest side, the middle angle across from the middle length side, the largest angle across from the biggest. So using law of cosines got us that first piece that we needed, that biggest angle measurement. Then we use law of sines to find the second angle, and then we can just subtract from 180 to find the third. So law of cosines is a great way to solve side, side, side. Well, how about side, angle, side? Let's take a look at that. Again, you'll see the same picture always. Your textbook was not very creative in this, but we have, in this case, a side, angle, side. So the included angle, so we have a side, angle, side here. So we have angle A, we have side B, and side C. So one thing I want you to notice right away, you have an A, a B, and a C, right? Two sides in the included angle. In the last one, we had an A, a B, and a C. So kind of a shortcut way for law of cosines to know that you need to use law of cosines. All three letters, right? You have an A, a B, and a C. What that means is you can't use law of sines. Because law of sines, you'd have a big A and a little a, or a big B and a little b, right? You have the side and the angle across from it. For law of cosines, we do not have that, and that's why we can't use law of sines. So we're going to solve and find everything in this. If you're doing side, angle, side, you have only one option of things you can solve for. The only thing you can solve for is the side across from the angle that you're given. So we really have no other choice. So in this case, we're going to have to be finding side A. So if you want to go ahead and back to your law of cosines, we have standard and alternate form. In this case, we have side, angle, side, and we want to find side A. So I'm going to go ahead and use that first one. So let's go ahead and jot that formula down. And we're going to substitute in those values. So I don't know a squared, but b squared is going to be 26 squared plus 19 squared minus 2 times 26 times 19 times the cosine of 62 degrees. This should be a pretty easy, what I would call a plug and chug, just like plug those numbers in and chug on through it. But for some reason, people have issues with order of operations on this. So if you're going to type the whole thing in, just type the whole thing in. If you're going to do it in pieces, be careful. Make sure you do the right pieces here. We have squaring, and we have product, and then we have adding and subtracting. And then ultimately, how do I get rid of a squared? Well, I'm going to have to square root. So let's start with just typing in everything as we see it here. So we're going to type that all in. All right, so let's double check. As you type it in, again, make sure that you're in degree mode. If you haven't changed it, you still are. So 62, finish off that parenthesis. We just need to do that entire order of operations. So for me, the easiest thing is just to type her all in. Okay, so I get 573, but remember that's what a squared is. So now I'm going to square root my answer, and I will come up with what side A is about. So it's about 23 point, we'll just round it to tenths again, about 23.9. So again, I have to square root that entire thing. Some people do that right away. They just put the square root in first. Doesn't matter though. You can decide which way you want to go with that. So that's going to be about 23.9. So I know what that side is. And again, it's going to be rounded. So I know I'm going to be using a rounded number, but that's okay. So now what do I have left to find? Well, two more angles, right? Angle B and angle C. So we have to think about, okay, what makes sense to find next? In this case, I would find the smallest angle next, because I know the smallest angle has to be acute, right? It's like, think about what you know for sure. The thing I know for sure is the smallest angle is going to be acute, so let's find that next. So which would be the smaller angle between B and C? Well, whichever one's across from the shorter side. So C is across from 19. I would find angle C next. But once again, do I have to use law of cosines? Well, No, because now I know everything about A, right? I have side A and angle A. So to find that second angle measurement or that second piece of the triangle, I can use law of sines. So we're going to find an angle. So I'm going to say find the smallest angle, or the smaller of the two angles. So the smallest angle, and we're going to use law of sines, because I know everything about one side and this angle opposite. So we're going to use law of sines. So just like the last one, I only have to use law of cosines once. All right, so we're going to set up everything we know about little a here. So 23.9 is to the sine of angle A, which was 62 degrees, and we're going to find angle C. So that's the smallest one, right? So we're going to do little c. 19 is to the sine of angle C. So same deal as last time, same kind of process. We're going to cross multiply and divide, and then take the inverse. So 19 times the sine of 62 degrees, divided by 23.9. And then we're going to do inverse sine, because remember we want what angle C is. So inverse sine of 19 times the sine of 62 degrees, divided by 23.9. Be careful on finishing out parentheses. I'm going to show you when I type this one in, where people can kind of fall apart here. So if I'm going to go ahead and type in that inside, 19 times the sine of 62, finish off the parenthesis. That parenthesis right there is the one that people forget, and then when you hit the divide, you're not dividing what you think you are. So just be really careful. Those little details can get you on these. All right, so we have our 0.7-ish. That's what the value in the inside is. Now I'm going to do inverse sine of my answer. And I get 44 point, we'll call her 6. So it's about 44.6 degrees. So we have angle C. And of course it should be acute, because we knew we were finding the smallest angle in the triangle, which definitely has to be acute. So 44.6 degrees. Now again, I know two angles already, right? So because I know two angles, I can find the third just from subtracting from 180. So we're going to find our last angle. So find the third angle. And we're going to subtract from 180. So go ahead and do that. So we're going to subtract from 180. So find that third angle. So that would be angle B. We're going to subtract off those other two. Looks like 73.4 degrees. So, and again, let's see if that seems like a reasonable thing when we look at our picture. So 73.4. So it actually, angle B is the biggest angle, right? Because angle A was in the middle. That side length was less than the 26. So it's good to find that last angle. It does end up that this is a acute triangle. So the biggest one we saved for last to see how much we had left. It did end up to be acute. So law of cosines first to find the only piece we could, the side across from the angle we were given, that side angle side, the included angle. And then we use law of sines to find our next angle, which was the smallest one because we knew it had to be acute. And then whatever's left from 180 is going to be that last angle. So those last two steps are always going to be the same here. We use law of cosines to find that first piece, and then we can use law of sines and subtract from 180 to find the others. So if we're solving for an entire triangle, we've got a strategy. All right, now let's talk about some applications. So we're going to do two different things here. We're going to talk about how do we calculate in these oblique triangles, meaning non-right triangles, using things like law of cosines to help us solve. So here's the first one we're going to do. We're going to do some softball. You could do the same thing with a baseball field as well. It says in a softball game, a batter hits a ball to dead center field. We'll talk about what that means. A distance of 240 feet from home plate. The center fielder then throws the ball to third base and gets a runner out. The distance between the bases is 60 feet. It's actually 90 on a baseball field. If you wanted to do this for baseball, you could do a very similar calculation. How far is the center fielder from third base? In other words, how far did he make that throw? So let's see if we can draw a picture. Can you draw yourself an infield of a baseball field here? All right, so I drew a very wonky looking infield here for a softball field, 60 feet between each of the bases. So I have home, first, second, and third. So what do they mean when they say dead center? That means right out straight from home over the pitcher's mound and then into center field. So kind of a straight line starting at home, over second base, and into, we'll call this center field out here. So how long was that hit? Well, that was a 240-foot hit, so 240 feet. So I know that that's 240. What happens next is that center fielder throws the ball to third, and that's what we're trying to figure out. How long was that throw? And then we do know down here that this is a 60-foot distance between the bases. So we have a triangle here. We have a triangle that's the blue side, the red side, and then the green side. So we do have a non-right triangle there because none of those are right angles. What do we know about that triangle? Let me see if I can draw it separately. So this is the triangle we're dealing with. So we have two sides. So think about what we need to know for law of cosines. We either need side, 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 or side, angle, side. Well, I definitely don't know side, side, side. That's what the question is asking me to find. I want to figure out how long that throw is. So is there a way that I could figure out the included angle to make a side, angle, side situation? Is that something I can figure out? Let's think about what we know about this situation. These are between the baselines, what angle do they meet at? 90 degrees. So if we do dead center field right down the middle, what would that leave for that angle over there? That would be 45 degrees, wouldn't it? So we actually do have side, angle, side. So we can just use law of cosines to help us find this side across from the angle that we know. So if we go back to our law of cosine scenario here, standard form versus alternate, it's side, angle, side. So we want to use this standard form, right? This first one. But our triangle isn't labeled. So here's the thing. In real life situations, they don't come pre-labeled. So you could put labels on the corners, whatever you want to call it. So you have something to talk about. That's totally fine. So you can pick any one of those. You could also switch it out. It doesn't have to be ABC. It could be DEF. But just notice in the formulas, no matter what you do, the side is what's across from the angle that you know. So those letters have to match when you're using your law of cosine. So whatever labels you want to use. So let's just say we use ABC. So we'll label it that way. So I'm going to call this angle A. So that means that's side A. And oh, I don't know, it doesn't matter here. So we'll just say that's B and that's C. So little b is the 240 and little c is the 60. That could be flip-flop, makes no difference at all. And then we can use our law of cosines to help us solve. All right, so I have my format here. So I just decided to do the ABC. Again, you could decide however you wanted to do that. So 240 squared plus 60 squared minus 2 times 240 times 60 times the cosine of the included angle, which was that 45 degrees. So I'm going to type that all in, and then I'm going to remember square root, right, because that's a squared, and I should have a pretty good idea of how long that throw was from center field out to third base. All right, so I have everything typed in. Pretty big number, right? But now remember, that's what a squared is, or that side squared. So now I'm going to take the square root, and oh dear, I did not take the square root. So try that of my answer. There we go. So it's about 202. And what units would that be in? When I square root now both sides, this was in feet, right? So we're going to be about 202 feet. So it's a pretty decent throw, right? That's how far you'd have to do that. Think about if it's 90 for a baseball field, you could replace the 60 with a 90 and figure out how much further it would be for a baseball field. So how long that throw would be. So pretty incredible so that they're able to have that kind of accuracy. I guess that's why in those situations, we want to be able to do those calculations. We know what we're dealing with, right? So we can find those. So side, angle, side was a great way to do that solving in a real situation. Now we're going to do one more. We're going to do a little bit with navigation, looking at different ways that we can solve. So how do we use law of cosines in real situations? So we're going to do a navigation one. We have talked about how to do headings and what that looks like. So we're going to be kind of coming back to that. So we have a ship that's traveling, and this is in your additional notes packet. So same as the last one. Hopefully you found that. The ship travels 40 miles due east. So the ship is starting here at point A. So this is where the ship was located originally. So when they say due east, they mean straight to the east. So not going up or down at all, from straight east. And then changes direction. So it changes direction at point B and starts going in this sort of northeasterly direction. What we're going to try to figure out, and they go 30 miles in that direction. Then they're 56 miles from where they started originally. So a straight shot from where they started originally to their new location, 56 miles from where it's left from. It's the point of departure. So describe the bearing from point B to C. So we know it's in the northeasterly direction, but we want to figure out how many degrees east of north is it, right? Because it's not going straight north, it's going a little bit to the east of that. So we know the heading had to be a little bit off from that. So that's what we're going to try to figure out. Think about what we know about the triangle. We have side, side, side. So we have three sides. So we should be able to find an angle measurement. Now, what would be the most helpful angle to be able to figure out the heading? Well, we need to know angle B, right? Because if we know angle B, then we can figure out how far it was off of this straight north. So we could figure out what that remaining value was. So if we know the whole angle measurement, we could figure out how much past 90 it actually went, right? How much to the east it actually traveled there. So let's see if we can find that angle B. Now remember, we're supposed to, if we have side, 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 find the largest angle first. Well, angle B would be the largest angle, right? It's across from the 56, so we want to make sure we do that calculation first. And it's definitely looking like it's going to be obtuse, right? So hopefully that's the case, because we know we went past 90, so it should be an obtuse angle. So we're going to find that angle B. So I'm going to go back, and I'm going to be, we got this side, side, side situation, right? So I'm going to be using the one that's written for B. And again, we put these labels on. You can label whatever you want. So go ahead and get your formula jotted. All right, so that's going to be cosine of angle B is equal to little a is 30, so 30 squared plus 40 squared minus 56 squared over 2 times 30 times 40. So let's go ahead and get that calculated. Okay, so I did my numerator, 30 squared plus 40 squared minus 56 squared, negative 636. 2 times 30 times 40, my denominator, and then I'm going to divide. So I get this negative 0.265. So cosine of B is that ratio. So that 2400 on the bottom and negative 636, I believe that's what it was, in the numerator. So that's my value for what cosine of B is. Once again, I don't want cosine of B, I want angle B, so I need to do inverse. So I'm going to do inverse cosine of that ratio. It doesn't matter about simplifying the ratio. I don't really care, because I'm just going to be finding the inverse cosine of it anyway. So I'm just going to go ahead and do that. So we're going to do inverse cosine of my answer. And that gives me 105 point, we'll call her 4. So 105.4 degrees. We could also do degrees, minutes, seconds, right? So we could talk about that. We could get as precise as we want to with that. So we could do degrees, minutes, seconds, which is probably in navigation what they would do, or just round it to decimal right now just to have that. So we have about 105.4. That's the whole angle B. Now remember, we're trying to figure out the heading. So if I had gone just straight north from this point B, that would have been a heading of due north, but I know I went past that. So this 90 degrees would be straight north. I'm trying to figure out how much further we went to the east. So we know the entire angle B is 105.4. I'm going to subtract off that 90 degrees, which would be the straight north heading. So that would leave me with 15.4 degrees. So this is 15.4. So I went 15.4 degrees past north. All right, so what's my heading then? So remember how to do that. So I'm going to say it's 15.4 degrees east of north. So we're going in the northeasterly direction, and it's 15.4 degrees past north. So it's kind of a great application to bring back other things that we've done. Anytime we're dealing with triangles that don't have right angles in them, we have to have other options. Law of sines and law of cosines are going to be the ways that we're going to solve. So it's just understanding, what do I know about my triangle? What law am I going to use to help me find it?